Hi, this is Engage in New York, Module 4, Lesson 9. Read the objective with me while I read it out loud. I can find a fraction of a measurement and solve word problems. So going back to Lesson 7 and 8, we were practicing with our measurements and converting measurements. And if you go back to right before Lesson 8, there was a reference sheet. This 5th grade, the centimeters, the conversion sheet. So you definitely want to be able to, if you don't have this, you want to write it down on a note card and have this available to you. All right, so that's what we're going to be working with, is finding a fraction of a measurement. A fraction of a measurement of feet, inches, pints, gallons, yards, kilometers, meters. That's what we're going to be doing. We're going to be finding a portion, finding a fraction of one of those things. But before we get started, let's go ahead and start with the fluency. So this fluency right here that we're going to work on reviews lesson 7. So what fraction of 8 is shaded? So here's our tape diagram. What fraction of 8 is shaded? You're right. 1/2 is. So 1/2 of this is shaded in, correct? All right, so 8 divided by 2 is what? So if I had 8 and I divided it in half, how much would be in each section? You're right, 4. So 8 divided into 2 is 4. All right, now, so 8 divided in half is equal to what? 4. So we can do this two ways. You can do it using cross-canceling. 2 goes into 2 once, 2 goes into 8 4 times, 4 divided by 1. Once you're going to cross-cancel, never mind on that. Let's just go 2 units is equal to 8. Take this down to 1 unit. What you do on one side, you have to do to the other. 8 divided by 2 is 4. So 1 unit is equal to 4. All right. Now, let's switch over to actually multiplication. This is where you can do your cross-canceling. Cross-canceling isn't going to work on division in this way because technically when you divide a fraction, you have to use the reciprocal. And when you use the reciprocal, it changes it to multiplication. Okay. So let's go back and think about this the same way we were thinking about this. If this tape diagram represents the number 35, and we have this broken up into sevenths, and remember, the denominator tells us how many equal sections there are. So if I want to find out how much is in one section, we can do that using this formula here, or you can cross cancel. 7 goes into 7 one time, 7 goes into 35 5 times, 5 times 1 is 5. Now, you could also go 7 units is equal to 35. Get rid of the 7, so you take it down to 1 unit. 35 divided by 7 is 5. I know that's 5. And if you know your multiplication facts, 35 divided by 7 is 5. That would help you too. 35 divided into 7 equal groups would give you 5 in each group. All right, now 16, and you're trying to find a fourth, 1/4 of the 16. So this tape diagram represents a whole number 16, and we have it sectioned into 4 equal sections. So we're trying to find 1/4 of 16. What is 1/4 of 16? So you could cross cancel. 4 goes into 4 once. 4 goes into 16 4. 1 times 4 is 4. Or an algebraic way, weigh 4 units is equal to 16. Get rid of that to take it down to 1 unit. 1 unit is equal to 4. So whichever way works best for you is the way to go. But this is probably a lot faster. Okay, moving on. This is just going to come back. It's going to come back and come back and come back. So understanding how to do that is going to be really important in the future. All right, now we have 16 again. But now we're trying to find 3/4 of 16. So here we go. 4 goes into 4 once. 4 goes into 16, 4. 3 times 4 is 12. And if we go here and go 4 units is equal to 16. 1 unit is equal to 4. But we want 3 of them. 3 times 4 is 12. So clearly this method is much quicker. But this method also is going to come back at some point. All right, now we're on to the whole number 48. The whole number 48 broken up into eighths, and we want to know how much is in 1/8 of 48. So let's start with cross canceling. 8 goes in 8 once. 8 goes into 48 6 times. 1 times 6 equals 6. Now, 8 units is equal to 48. 8 divided by 8. 1 unit is equal to 6. We know it is 6. There are 6 markers, 6 items in each section. And you put all the sections together and you get 48. All right, now we have 48 broken up into eighths again, and we want 5 sections this time. So 8 goes into 8 once, 8 goes into 48 6 times, 5 times 6 is 30. Let's see if we get it the other way. 8 units is equal to 48. Divide here. What you do on this side, you have to do on this side. This cancels out, becomes 1 unit. This becomes 6. But now we need 5. So 5 times 6 equals 30. So 1, 2, 3, 4, 5 would equal 30. All right. Now, that right there is a review of lesson 7. Now we're going back to converting measures. So if you need your reference sheet from lesson 8, go ahead and do that. So this is preparing you for lessons 9 through 12. And after lesson 12 is the mid-module test. So, and just spoiler alert, a lot of this is going to be on the mid-module test. All right, hopefully you're ready. All right, so let's go back to what we talked about the other day. Remember, it's just from pints to cups, and then we went through and figured out the same measurement is the same factor is being multiplied each time. So 1 pint is equal to how many cups? Do you remember? 2. So 1 times 2 is 2. 2 pints equals how many cups? 4 cups. 2 times 2 is 4. 3 pints was equal to how many cups? Well, it's times 2, right? So it's 6 cups. 3 times 2 is 6. 7 pints, how many cups would you need if you had you had pints in the refrigerator, but the recipe you were making called for cups? Well, 7 times 2 is 14. You would need 14 cups. 7 times 2 is 14. All right, now feet to inches. Let's see how you do feet to inches. So hopefully you remember this. 1 foot is equal to how many inches? You're right, 12. 1 times 12 is 12. So if 1 foot equals 12 inches, 2 feet equals how many inches? Good, 24. 2 times 12 is 24. So you notice the pattern going on. 4 feet equals how many inches when we're multiplying by 12, right? 4 times 12 is 48. 4 times 12 is 48. Okay, moving right along. Now, yards to feet. So 1 yard has how many feet in it? If you went to the fabric store or you went to Home Depot or Lowe's and you had to create a fence or a garden and you knew you needed 1 yard of material, fencing, how many feet would that be? And it was only sold in feet. So you'd have to know that. 1 yard is equal to 3 feet. So 1 times 3 is 3. 2 yards is equal to how many feet? So what am I multiplying by? 3. So yards to feet. 2 yards is equal to 3. 2 times 3 is 6. 2 yards is 6 feet. 3 yards, 3 times 3 is 9 feet. 9 yards is equal to how many feet? 9 times 3 is 27. And then 9 times 3 is 27. All right. Now, so these are different types of measurement, right? So pints and cups have to do with liquid, generally speaking, because pints are going to be liquid. So you're going to need cups and liquid. Feet is length, inches is length, yards is length, feet are length. Gallons and quarts, that's going to take you to liquid. All right, so here we go. So 1 gallon is equal to how many quarts? So a pint, this is a pint. It's the little small container, but a quart are the long skinny containers. So how many quarts are in 1 gallon? Well, there's 4 quarts in a gallon. 1 times 4 is 4. So if it takes 4 quarts to make 1 gallon, how many quarts will you need to make 2 gallons? So 2 times 4 is 8. Then 3 gallons, 3 times 4 is 12. 3 times 4 is 12. Then 6 times 4 is 6 gallons would need 6 gallons equals 24, excuse me. 6 times 4 is 24. All right. So let's look at that one more time. Look at how we're multiplying. And it's the same unit of measure in each section when you're going from pints to cups, feet to inches, yards to feet, gallons to quarts. All right, now the next part of our fluency reviews lesson 8, what we were doing in lesson 8. Okay, so remember yesterday, or in lesson 8, we were talking about copies of versus how many in a portion of a set, or how many copies of. So 4 copies of a half, or so that would be like the repeated addition, or half of a set. So that's what we're going back to. So just knowing that multiplication is repeated addition is really is just here to remind you that it's really just a reminder. And what it's trying to remind you of, that there is 4 copies. It's 4 times that you have 1/2. All right, so, or half of 4. So there's just different ways of looking at it, and being able to look at it and toggle back and forth between both perspectives is a good thing to be able to do. All right, so 1/2 of 4, so half of 4 is 2, but if you want to use 2 goes into 2 once, 2 goes into 4 2, 1 times 2 is 2. 4 copies of a half, so 1/2 plus 1/2 plus 1/2 plus 1/2 equals 2, right? So 1/2 times 4, so you could also do 1 times 4 over 2, which is also 2. All right, just understanding the different ways to manipulate and understand how that works is just a skill. All right, let's go through, and I'm going to have you go through and solve these on your own, and then I want you to come back and see how you did, because it is a review of yesterday. All right, I used cross canceling to make it quick. So 2, 4, 6, 6, 9, 3. How did you do? Hopefully you did really well. All right, the last part of our fluency today is an application problem. All right, now this is such a typical problem that you would see on a test. So getting good at this kind of thing is going to be really important. So there are 42 people at a museum. 2/3 of them are children. How many children are at the museum? So what I want you to do, I want you to attempt this problem. I want you to start it out. So how are you going to do it? What's the fraction? So remember, it's right now our objective, what we're working on, is multiplying a fraction to a whole number. So always going back is, what are we doing right now? What is the focus of what we're doing right now? We're multiplying a fraction by a whole number. So I want you to go ahead and try it. I also want you to try drawing a tape diagram and showing me what exactly you just did with your problem, how you solved it. All right, come back and show me come back in a minute to check how you did. All right, did you draw your tape diagram that represent a whole of 32? Did you break it up into 2/3? Then I went back to what I modeled before. 3 units is equal to 42. So I got rid of the 3 units, and I wanted to take it down and just find out what 1 unit was worth. So when I divided, what I do on one side, I have to do to the other. I ended up with 1 unit equals 14. And now I did 14 times 2 because I wanted 2/3. 14 times 2 is 28. There are 28 children at the museum. Is truly the answer. Making sure you give a full, complete answer is important too. All right, the extension part of this. So, you know there are 28 children, right? But what if 13 of the children are girls? Okay, now this is the important part. How many more boys than girls are at the museum? So this is definitely going to be a 2-step problem. Can you attempt the first step? What would you do first? So you're only concerned with the children at this point. So are you going to worry about the 42? You're only worried about the children. So what number are you going to work with? You're only going to be working with 28 children at the museum, right? So what would you do first if you knew there were 28 children at a museum and 13 of the children are girls? What would you do first? Would you subtract? Hopefully you would. 28 subtract 13. That's going to give you 15 boys. Now we know there are 13 girls, right? And that would take us back to 28. So if there are, well, that tells us how many boys, right? But does it answer the question? How many more boys are there than girls? What do you need to do next? Well, you need to subtract again, right? 15 minus 13 is 2. There are 2 more boys than girls. So notice the way I talked myself through this problem. I had to ask myself, well, am I considering all the people at the museum? No. I'm only considering the children. Okay, so I know there are 28 children. If 13 of the children are girls, how many are boys? Okay, so 28 minus 13 is going to give me 15 boys. But now, wait a minute, that's not the answer to the problem. I always have to go back and check, am I answering the question? All right, that's going to do it for our fluency practice for Module 4, Lesson 9. Meet me back here for concept development, where we're going to be taking a fraction of measurement, right? Fractions of measurement is where we're going.